So hello, welcome to my YouTube channel. So my name is Sushil Singh. Today I am going to present the topic of decoder, and so let's start our topic. So what we will discuss in this topic, let's see. So first will discuss that what is decoder, then its applications of decoder, then its logic circuit. Then we will see some examples of decoder, 3 to 8 and 4 to 16 decoder. And then we will also implement the 4 to 16 decoder using the 3 is to 8 decoder. Then we will see some implementations of logic circuit using the decoder. So basically decoder is just like a multiplexer, but only difference is that it hasn't any data lines. So basically, a decoder consists of the n input lines and 2 raised to power n output lines, and it also has a extra input that is the enable input. So it is a combinational circuit that changes the binary information to the 2 raised to power n output lines, and it has n input lines and it gives the 2 raised to power n output lines, and it is just like a demultiplexer, and it performs the reverse operations of the encoders. So for every decoder, output line is not always equals to the 2 raised to power n. It is generally equals to or less than equals to the 2 raised to power n output lines. So now is the logic circuit of the decoder. So decoder has the n input lines, 2 raised to power n output lines, and one that this is the enable input. So based on the input of the decoder, one of the output line will be selected. So let's see its applications. So first application that it is used for the conversion of the code, like binary to decimal it is used, and then it is also used for the data distribution, and it is also used for the address decoding, and also for generations of the control signals. And it is also used for the data transfer. And the last is that it is also used for the implementations of the logic circuits. So let's deeply go through the applications of the decoder. So first is the code conversion. So it converts the binary number into the octal number. For example, uh, if you take the 3 to 8 decoder, if you take the input 0, if you, so let me change the color. So if you take 0, 0, 0. So first output, that is D0, will be active and other will be inactive. So if you change it to 0, 1, 0, then D1 will be active and other become low. So, so there is also applications of the decoder, that is the binary to decimal converter, and it is a trim version of decoder, and it has the 4 input lines. But according to the law of decoder, that it should have 16 output lines, but it hasn't. So it's general thing that output line should be equal to the 2 raised to power n or less than the 2 raised to power n. So if its input is 0, 0, 0, 0, so its D0 will be active and other become low. That is the code conversion. Let's move forward toward the next application. It is also used for the generations of the control signals. So it takes the input from the microprocessor and gives the output. And its output lines are used for controlling the peripheral devices and also used for the control of the internal circuits. Internal, used for the controlling the functionings of the internal circuits. So next is the address decoding. So in the modern in the modern time. So laptop contain doesn't contain a single memory chip. It contain a multiple memory chips. So to connect all that memory chips interconnected to the microprocessor, we use decoder. So depending upon its input lines, so one of the memory will be selected, and that is used for storing something or reading something according to we need. So if it is zero, first input line is zero, and other is also zero, the first memory will be selected. And if the first line is one and other is zero, then second memory will be selected. So according to the inputs, respective memory will be selected. So it is also used for the address decoding. So its last implementation, that it is also used for the implementations of the logic circuits. So we can give the output to the logic circuit, basic logic circuit like AND gate, OR gate, and to get the required results. So after the applications of the decoder, let's take some examples of the decoder. So firstly, we take a 3 to 8 decoder. 3 to 8 decoder has 3 input lines and 8 output lines. So based on their input, so one of the 8 output will be selected, and I will show you the truth table in the next slide. So here is the truth table of the 3 raised to 8 decoder, and here is its logic circuit. So these are the 3 input lines which are connected to the each and every AND gate, and there is also a enable input that is connected to it, but it is not showing here that it this enable input is connected to the every AND gate. So without these, logic circuits is not working. If it is low, then it will not show any output. So based on their input, so let's take a 0, 0, 1, that is 4. So that is that this one is active and other become low. If you take the enable 0, then all the respective output will be 0. If you take the enable 1, and if you take all the inputs 0, 0, 0, then the y0 will be active and other become low. So this is a 3 to 8 decoder. Let's see 4 to 16 decoder. So 4 to 16 decoder is just same like 3 to 8 decoder, but it has 4 input lines. And other than 4 input lines, there is also enable input and 16 output lines. So same principle in 3 to 8 decoder. It has it so based on these 4 inputs, one of the output will be selected. So this is the 4 to 16 logic circuit. So if the enable is low, then it doesn't show any output. So if enable become active, only then it show output based on their inputs. So if we take 0, if we take 0, 1, 1, and 1. So it shows that is 8 for 12 and 12 plus 16. 12 plus 2, that is 14. So Y13 will be active and other become low. So now we will see that how we can implement the 4 is to 16 decoder using 2 3 raised to 8 decoders. So so with the help of enable, we can implement the 4 to 16 decoder using the 3 to 8 decoder. So we will provide enable to the one, and the not of that enable will be provided to the other 3 to 8 decoder. So if the A3 is 0, So a verb decoder will be active, and then the decoder that is down will be inactive. So depending upon their input, output will be displayed. So in this way, uh, we can implement the 4 is to 16 decoder using through. So in the same manner, we can also implement the 5 raised to 32 decoder using the 4 3 raised to 8 decoders. So this will be implemented with the help of one decoder which contain the 4 enables that are connected to the 4 3 raised to 8 decoders. So if depending upon their inputs, one of the decoder will be active, and then we will provide the input to that decoder, and the respective output will be displayed. So then last is that is the how we can implement the full adder using 3 raised to 8 decoder. So adder is basically a that it adds two bits and produces the output sum and carry. That's why it is known as the adder circuit. So its truth table is that here is the sum and here is the carry. So these are the sum. Sum is active at 1, 2, 4, 7, and carry is active at 3, 5, and 6 and 7. So with the help of the OR gate, we can implement the sum and the carry. So sum is active at 1, 2, 4, 7. So 1, 2, 4, 7 is connected to the OR gate that represent the sum, and 3, 5, 6, 7. We should connect it to the OR gate that represent the carry. So thank you guys.